Hello friends, today's topic is relation and function. Myself NB Pandya, PGT Maths. Okay, so we start from relation. As you know, relation, a relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. So in other words, what is the relation? Relation is a subset of Cartesian product. In this, the second element is called the image of the first element. The set of all first elements of the ordered pair in a relation R is called the domain of the relation R. The set of all second element in a relation R is called the range of the relation. So here two things, first is domain and second one is range. And at last, the whole set B is called the codomain of the relation R. Next, we start from type of relation. This is your previous knowledge, and in this chapter we will start from type of relations. So number one, a relation R in a set A is called empty relation if no element of A is related to any element of A. Okay. Second thing, a relation R in a set A is called universal relation if each element of A is related to every element of A. It means R is equal to itself A cross A. Both the empty relation and the universal relation are sometimes called trivial relations. Okay. Then through example, let A be the set of all students of a boys school. Show that a relation R in A given by R is equal to AB such that A is a sister of B is the empty relation and R dash is equal to AB. The difference between height of A and B is less than 3 meters is the universal relation. So for this example, the school is the boys school. No student of the school can be sister of any student of the school. Hence this given relation is empty, because in the school no girl student present, because school is only boys school. So this relation is empty, showing that R is empty relation. Okay. It is also obvious that the difference between height of any two students of the school has to be less than 3 meters. So this shows R dash is equal to A cross A is a universal relation. Next, very important definition. A relation R is a set A is called reflexive if AA belongs to R for every A belongs to A. Second one, symmetric if A1 A2 belongs to R implies that A2 A1 belongs to R for all A1 A2 belongs to A. And lastly, third one, transitive if A1 A2 belongs to R and A2 A3 belongs to R implies that A1 A3 belongs to R for all A1 A2 A3 belongs to R. So here a relation R is called reflexive, symmetric and transitive. Then a relation R in a set A is said to be equivalence relation if R is reflexive, symmetric and transitive. जो हमने just अभी स्टडी किया कि what is reflexive. So reflexive means A belongs to R. Symmetric means A1 A2 belongs to R implies A2 A1 belongs to R. Transitive A1 A2 belongs to R, A2 A3 belongs to R implies that A1 A3 belongs to R. So a relation R in a set A is said to be equivalence relation if R is reflexive, symmetric and transitive. Example 2. Let T be the set of all triangles in a plane where R a relation in T given by R is equal to T1 T2, T1 is congruent to T2. Show that R is an equivalence relation. Solution. R is reflexive. Why R is reflexive? Since every triangle is congruent to itself, further T1 T2 belongs to R. It means T1 is congruent to T2. This implies T2 is congruent to T1. So T2 T1 belongs to R. Hence R is symmetric also. Moreover, T1 T2 T2 T3 belongs to R. It means this implies T1 is congruent to T2 and T2 is congruent to T3. This implies T1 is congruent to T3. This implies T1 T3 belongs to R. Therefore R is an equivalence relation. So this is a very simple example. One more. Let L be the set of all lines in a plane and R be the relation in L defined as R is equal to L1 L2 such that L1 is perpendicular to L2. Show that R is symmetric but neither reflexive nor transitive. R is not reflexive as a line L1 can be perpendicular to itself. L1 L2 does not belongs to R. R is symmetric as L1 L2 belongs to R. So L1 is perpendicular to L2. This implies L2 is perpendicular to L1. L2 L1 belongs to R. R is not transitive if L1 is perpendicular to L2 and L2 is perpendicular to L3, then L1 can never be perpendicular to L3. In fact, L1 is parallel to L3. L1 L2 belongs to R, L2 L3 belongs to R, but L1 L3 does not belongs to R. So in this relation, this is symmetric but neither reflexive nor transitive. Example number 5. Show that the relation R in the set Z of integers given by R is equal to AB such that 2 divides A minus B is an equivalence relation. This is a very important question for examination point of view. Here R is reflexive as 2 divides A minus A for all A belongs to Z, because A minus A itself 0 na, so 2 divides 0. Same thing, R is reflexive as 2 divides A minus A for all A belongs to Z. Further, if AB belongs to R, then 2 divides A minus B. Therefore 2 divides B minus A also. Hence BA belongs to R, which shows that R is symmetric. Similarly, if AB belongs to R and BC belongs to R, then A minus B and B minus C are divisible by 2. Now A minus C is equal to A minus B plus B minus C is even, because two even numbers, because previously A minus B and B minus C is also divisible by 2. So both even numbers we added, then again we have one even number. So A minus C is also even, and it is clear that A minus C is even, then A minus C is also divisible by 2. This shows that R is transitive, thus R is an equivalence relation in Z. Okay, clear? Then question number 3. This is a NCERT book exercise question. check whether the relation R defined in the set 1, 2, 3, 4, 5, 6 as R is equal to AB such that B is equal to A plus 1 is reflexive, symmetric and transitive. So for the solution, let A is equal to 1, 2, 3, 4, 5, 6 is a set. A relation R is defined on set A as R is equal to AB, B is equal to A plus 1. So R is what? 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 because B is equal to A plus 1. So if we use A as a 1, then your B is 1 plus 1 2, your A is 2, then B is 2 plus 1 3, like this way 5 6 4 5 3 4 2 3 2 1. We can find AA does not belongs to R. Ab AA does not belongs to R, it means A is your first element and A is also your first element and same. Not possible. A 1 1 2 2 3 3 4 4 5 5 6 6 does not belongs to in the given relation, given definition. So R is not reflexive. It can be observed that 1 2 belongs to R but 2 1 does not belongs to R, so R is not symmetric. Now 1 2 2 3 belongs to R but 1 3 does not belongs to R, so R is not transitive. Hence R is neither reflexive nor symmetric nor transitive. Clear everybody? Okay. Question number 5. Check whether the relation R in R defined as R is equal to AB such that A is less than R equal to B cube is reflexive, symmetric or transitive. Here R is AB, A is less than or equal to B cube. It is observed that 1 by 2 and 1 by 2. We take 1 by 2 as a, so AA does not belongs to R since 1 by 2 is greater than 1 by 2 cube. So R is not reflexive. Now 1 2 belongs to R as 1 is less than 2 cube, it means 8. But 2 1 does not belongs to R as 2 cube is greater than 1. So this is not a symmetric relation. Next, for transitive, we have 3 3 by 2 3 by 2 6 by 5 belongs to R. Since 3 is less than 3 by 2 whole cube and 3 by 2 is less than 6 by 5 whole cube, but 3 6 by 5 does not belongs to R as 3 is greater than 6 by 5 cube, so R is not transitive. Through this we say R is neither reflexive nor symmetric nor transitive. Okay, so this is a very important question, and clearly you see what type you prove: reflexive, symmetric and transitive. So reflexive, AA belongs to R. Symmetric, AB belongs to R. This implies BA belongs to R. Transitive, AB belongs to R and BC belongs to R. This implies AC belongs to R. This much. Thank you.